resistance in parallel. So we have three resistors R1, R2 and R3 connected in the parallel configuration, and there is a voltage source. When switch is on, the current will flow in the configuration. At this point in junction, the current has three different paths. One path along with the R1, second path along with the R2, third path is along with the R3. So the I would be divided into three different values: I1, I2, I3. This I1 will be flowing through R1, I2 will be flowing through the R2, and I3 will be flowing to the R3. So according to the Ohm's law, I is equal to V upon R. So this would be, V would be same in the parallel configuration. So V would be divided with the R1 to get I1. For I2, V would be same. Resistor value would be different as R2. And I3 would be V3 upon R3. So taking V as a common, we are getting V in bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. So V would be cancelled. The equivalent resistance of the resistance connected into the parallel would be 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we can conclude here that the equivalent resistance of the circuit where resistors are connected in parallel would be the lesser value than comparative to a single resistor already there like R1, R2 and R3 if the circuit is connected into the parallel. So if we are going for this type of summation, then equivalent resistance would be less value than individual R1, R2 and R3 values.